I decided in this introductory video to Haskell and the different aspects of Haskell programming language to give you a little gist of what Haskell programming language is about. So this video is not scripted or anything. I just wanted to share with you that I'm currently reading this book about Haskell. It's amazing. It's great. It's by O'Reilly. Right? You can order it on Amazon. And it has very good chapters explaining everything from the basics and then progressing with you along the way, like giving you some projects, some homeworks to solve, It's a great book, and I wanted to share with you in a non-traditional way what I've learned so far about Haskell. And what I've learned so far is not little. So I've been reading this book for over 3 months now. This is probably the only book that I'm reading night and day whenever I have the possibility, of course. Haskell is a very widely used, purely functional programming language. So when I talk about purely functional programming language, here there will come to your mind the difference between imperative and declarative. Functional programming, like Haskell, is declarative. You tell Haskell what the thing is, not how to do the thing. In contrast to imperative programming, like in JavaScript, in Rust, right? C, C++, all this is imperative. It's not declarative. These languages that I've just mentioned are not functional. In JavaScript, you can use, there are functional features, but it's not functional by default. So, besides Haskell, some of the other popular languages that follow the functional programming paradigm, Lisp, I haven't studied or I haven't worked with those languages, but besides Haskell, there is Lisp, there is Python, believe it or not, Erlang, F#, Clojure, very popular as well. And Haskell is more intelligent than other programming languages such as Java, C++, PHP, etc. Now, the prerequisites, just to move along with me, although it's a tutorial for beginners, I will assume that you have reasonable exposure to any other programming environment. You know what variables are, you know what data types are, how to create functions, loops, if-else statements, Okay, so don't expect me to explain programming more than I will be explaining functional programming and specifically Haskell. Now, I have a video where I've explained how to install the Glasgow Haskell compiler and interpreter. I will leave a link to that video in the description somewhere below, and you can check it out. It's really easy. You will go to the website, copy the command, you will paste it to your terminal, you will hit enter, and that's it. I don't think it's a big deal. But for now, I want to open the interpreter. So this is Haskell interpreter. So back to the conventional and functional programming. In conventional programming, instructions are taken as a set of declarations in a specific syntax or format, right? So in something like JavaScript, you declare a variable, you create a function, you can have side effects. A simple example for side effects is just printing something to the console when you do console.log. This is a side effect of your program. This doesn't exist in functional programming. In Haskell, we don't have any side effects, right? There is no mutation between the input and the output. And that's really powerful. Haskell does not change things. If you will, there is a function, you enter an input, you will get an output. That's it. There is nothing in between. There is no unexpected behavior in Haskell programs in general. And this is very suitable for the banking sector, for example, the finance, because they need to basically have stable results in terms of the finances and the statements and all of that. It's going to be disastrous if there are some changes in the results. So functional programming, and specifically Haskell, is very suitable for finance and banking, the banking sector in general, creating applications, programs designed or tailored for the banking or the finance sector. Also, it's great for academia. So it's used for, scientific researches, academic researches and all of that. So in functional programming, all the computation is considered as a combination of separate mathematical functions. So you have separate mathematical functions. They are, gathered together, like grouped together, and creating your application. We'll see that when we'll come to the module. So it's modular. Haskell, it's called a modular language because each function is considered to be a small application. Right. So this is what is functional programming all about, right? So in conventional programming language, something like C, JavaScript, Java, whatever, you instruct the compiler a series of instructions, right? So it's nothing more than you telling your computer exactly what to do and how to do it. In Haskell, we tell the computer what it is. So you don't tell your Haskell program what to do or how to do, rather you tell it what it is. That's it. So again, I'm repeating that point because it's very important. Haskell programming language is a functional programming language. It's based on functions, on mathematical functions. So let's say, for instance, that I want to create a function, and that function is going to take a number and it's going to return the square number of that number. So let me create this square. It takes x and it returns x multiplied by x, right? Now, if you will do square 23, you will get 529. This is an execution of a function. It's basically all the function. It's a program. It's a simple program that takes a number and takes an input, returns you an output. That's all what it does. Another thing in Haskell is something called laziness. And by laziness, I mean that Haskell will not evaluate any expression without any reason. So if you're going to give Haskell an array of million, from 1 to million, for example, it's going to be lazy, idle, It's not going to use it unless you're going to call on that array, or you're going to use some function using that array. In other words, when the evaluation engine finds that an expression needs to be evaluated, it's going to create something called thunk data structure. Thunk, T-H-U-N-K. T-H-U-N-K, thunk data structure. This thunk data structure collects all the required information for that specific evaluation and a pointer to that thunk data structure. Okay, and it's also related to garbage collection. I'm going to talk about garbage collection later. So again, this evaluation engine in your Haskell programming language starts working only when it's required to evaluate that specific expression. Other than that, it's not going to touch it. And that's why it's called lazy programming language. Why lazy? Because it's not going to evaluate unless it's asked or required to do so. And let me give you an example. Let's say I want to define an array from 1 to infinity, right? So let me say let infinite list, right? Infinite list is equal to 1 to whatever, to the infinity, okay? If you want to take the first 10 elements from that infinite list, you can do so. And that's using a very interesting function in Haskell called take. So we take the 10 first elements from the infinite list. Oops, I misspelled that. Okay, let's do like this, infinite list, right? Now, again, let's take the 10 first elements. Sorry for that technical error, guys. And there you go. You have a list from 1 to 10. Only from 1 to 10 in that infinite list that originally is from 1 to infinity. It's going to compute elements only when they're explicitly needed. The take is very interesting function. It does what it says, right? It takes whatever is the number of elements inside that list and returns them inside the list. This is a list, right? An array in JavaScript, a list also in Python. Here, for example, you can say true. This is Boolean. You can say here false, right? It's going to return true or false. If you're going to add a string to the list, it's going to yell at you. So if you'll do, this is a string, right? You will have, of course, an error. It's a type error because couldn't match expected type bool with actual type car. So that's interesting, just I wanted to show you that. The next characteristic of Haskell is modularity. So any Haskell application is nothing but a series of functions, like I've told you in the beginning of this video. So you can say that a Haskell application is a collection of numerous small applications. They are all combined together, forming your whole application. So each function is considered to be an application in itself. Let's say that I want to have a double that takes x and multiplies x by 2. Also, let me have a number that's being incremented by 1. So let's call it increment, right? That's x, and that's, basically adding x plus 1, incrementing x by 1. So we have double, we have increment. Now, let me combine those two functions to apply both to a number. So naturally, I'm going to call that double. So I'm going to have double, and then I'm going to increment it. So I'm going to multiply by 2 first, and then after I will add 1. So say double, then increment, something like that. And that's going, that takes x, of course, as an input. And that is going to, call for increment. And then is going to, let's just make like that, passing double for that x. Again, I apologize, guys. I don't know what's going on. I think it's the shades that I'm holding because the sun is really bothering me. So I really apologize. Again, with the double. So there we go. Now, if I want to use that double then increment, I can do. So you see what we have done, right? We have actually created double. That's a function on its own. Then increment, that's a function on its own. And then we have done this. We have taken increment and passed inside increment double x. So we're going to double first, and then after the result is going to be passed as a parameter or argument to that increment function. Right, so let's put this to test. Double, then increment, and let's say for instance 10, and we get 21. Why 21? Again, 10 multiplied by 2, that's 20, plus 1, that's 21. So it's the correct result, 21. Also, Haskell is statically typed. I personally love all the static typed programming languages. So in conventional programming languages, not functional, right? You need to define the type of the variable that you're declaring, right? You will say, for instance, const number or const a, and you will do type annotation, and you will define or decide the type that you want to give to that variable. However, in Haskell, it's intelligent enough to figure out on its own the type of the variable declared. So if I want to create a function, for example, I can say this is a function, and then I will do type annotation, that's an integer, and I need it to return an integer, right? In Haskell, you don't have to do that really. So I will change the name of that function. I will say that's auto-inferred function. That's going to be x. Again, it's taking x and multiplying it by 3, for example. That's the cube. So you can do auto-inferred function 10, and it's going to return 30, right? It didn't complain. It didn't ask you to define the type. The last great feature in Haskell is maintainability. So Haskell applications are modular, as we said. So they are composed of those small applications, small functions grouped together. It's like Lego. And therefore, it's very easy and cost-effective to maintain them, right? Because if there is an error, we will know exactly where the error lies. So if you have a program that is composed of 10 different applications, 10 different functions, if you will have an error, immediately it will point to that function. There is an error in that function. So you will go, you will, do the debugging. You will basically save your time and effort. Let me give you an example on maintainability. So lately I've been fond of temperatures. I don't know. I've created this, it was yesterday or maybe today. Oh, it was today, this morning, early in the morning. I've created this converter Celsius to Fahrenheit and Fahrenheit to Celsius in Node. So maybe I can take the same example actually and show you what I mean by maintainability here. So let's say, for instance, that we have a simple function that converts temperature from Celsius to Fahrenheit. So over time, you decide you also want to support conversions from Celsius to Kelvin, for example. You can define a function to convert Celsius to Fahrenheit. So initially, I'm going to just give a name to that function, CTF, Celsius to Fahrenheit, and that takes C, which is going to be the Celsius degrees, and it's going to just C, it was multiplied by 9/5 plus 32, I think, if I'm not mistaken. Whatever, it's not the point. I think it was the input 9 divided by 5 plus 32. All right, so okay, not in scope. Okay, sorry, needed to do let, and maybe let's do CTF like that. That's going to be the name of the function. All right, didn't complain. Also, let me create a function that's going to take from Celsius to Kelvin. So we'll do CTK, and that also takes C, and that's going C plus 273. So we have CTF and CTK, both functions do conversions from Celsius to Fahrenheit and from Celsius to Kelvin. Now, if we'll do CTF 20, that's going to return us the result, 68. And if you'll do CTK 20, that's going to also return us the result. This approach highlights the Haskell's maintainability. How? It has shown me that how easy it is to add new functionality. So a new temperature scale conversion, for example. And that's without, risking or disrupting any existing functionality. So each function is self-contained and self-maintained as well. All right, so as I told you, in finance, in banking, you will never have any bugs. You will not have any unexpected behavior because you have an input, you have an output. It's simple as that. You have independent applications, independent functions. All they are self-contained and self-maintained. Haskell, by the way, was created by mathematicians. So it's founded on mathematical solid ground, okay? That's why I love it, maybe. And you don't have to be a genius in mathematics. Even you don't have to be good in mathematics or love mathematics, because everything is going to make sense once you apply yourself. Why we hated mathematics at schools? Because we haven't applied anything. We had to know rules and, do the exams or pass the exams and answer questions on the paper, but we didn't find any tangible result, or not tangible, but any real result. However, when you start create applications, even small applications, and you're going to apply the rules of functional programming, everything is going to be, to fall in place. Everything is going to make sense for you. Now, a simple hello world, we have seen it many times. I have one video about Haskell. I have other videos, but I haven't done the editing yet. But, a simple hello world, you will just create main. That's going to be a function naturally, and that's, we'll have here, like print in Python, or println exclamation mark in Rust, or console.log in JavaScript. We would do put strln, and you will say hello world. Right, so that's hello world. So let's talk a little bit about the basic data models of Haskell. They are actually predefined or somehow decoded into the computer memory. So let's start by numbers, for example. So Haskell is, as we said, intelligent enough to decode some number as a number through the type interference. So you need not to mention the type, as we said. So you can do something like that. You can do addition, you can do multiplication, you can do division, right? And you can do subtraction. Okay, so you can do all of the basic mathematical operations. You can do, for instance, 100 plus, let's say, 23 multiplied by 43, whatever, minus 40. And you will have the result, 1049. Now let's move to characters. Like numbers, Haskell can, again, intelligently identify a character given in as an input to it. So we can do, for instance, A, that's going to, produce this output A. That's a character. If you want to specify the type, you can do colon T, and then you can do A. And that's going to give you that A is a character data type. If you'll say false, that's going to give you this output. It's a Boolean. False is Boolean data type. If you will do 23, if you'll do 23, that's going to be number. However, if you will do S, for example, without the double quotation, you will get an error. And the error says here that variable not in scope. There is an error. Why we have this error? Simply, Haskell compiler is just warning you that it's not able to recognize your input. So by this error message, Haskell is telling you that it's not able actually to recognize this input. If you will do S like that, that's fine. If you will do 2 like that, that's also fine, because you wrapped double quotes around a number. The same thing like a string, right? If you do like this, it's going to give you character. However, if you will do like this, it's going to tell you that this is a Boolean data type. And speaking of Booleans, it's pretty straightforward like any other programming language, basically. So if I will say true and true, that's going to give me true, that's truthy. If we'll do true and false, that's going to be falsy. If we'll do true or true, so this is or, right, in Haskell, that's going to be true. true or false, we're going also to get true. So be careful that true is capitalized, the T and the F. So if you will do true like that, it's going to tell you that perhaps you meant data constructor true, imported from Prelude. Now let's see lists, for example. List is like in any other programming language, actually, that's a list. So inside the list, you have to have homogeneous data types. You can do 1, 2, 3, that's okay. But you cannot do 1, 2, 3, and, you know, frog, right? You can't do that. You'll have an error. You can also have lists within lists, but under the condition, again, that the data types should be homogeneous in all of the lists. So let's say that we have a list. The first list has 1, 2, 3. The second list has 4, 5, 6, and the third list has 7, 8, 9. Okay, so we have 3 different lists in one big list. And let's do number list, right? So number list in this case, it's not going already, it didn't give us any errors. So if you'll do number list, we will have those 3 lists in one big list called number list. And you can do the same with Booleans, with characters, with strings, you know, with any data type. So we can also generate lists using mathematical expressions. So I'm talking about list comprehension. So let's say, for instance, that I have a list from 1 to 5, and I want to apply a square number on each number. So I want the square number of 1, the square number of 2, the square number of 3, and so on. So the way to do that in Haskell is you would do x multiplied by 2. So that's the square number of whatever the x is, whatever the input is going to be. Then you will separate that by a pipe, and that on that x as an input, you want to, you know, iterate through that list of numbers and do this operation x multiplied by 2. So this is the way to do it in Haskell. So that's going to be from 1 to 5 or 6. Yeah, let's do 5. Okay, so there we go. 2, 4, 6, 8, 10. It took each number and it has actually multiplied by 2 and returned the result inside a list. So this is list comprehension. You can make it bigger, for example. You can make it bigger. Haskell is going to return the result without altering or changing anything. This is the power of functional programming. It's simple. You need to understand the function, how it works. It's clean. I find it very clean. I don't know. Let me know what you think, guys, in the comments below. But I find Haskell is a very clean language. If you would do the same, but without multiplying anything, that's going to return the same numbers from 1 to 100. In Haskell also you have tuples. So a tuple is basically a compound data type. It's just heterogeneous data types inside parentheses. That's all what it is. You can include numbers, you can include characters, strings, booleans, no problem. It's the opposite of lists, right? So if you'll say this is my list, maybe you can clear the terminal, right? So 2, 3, you can have string, you can have true, and no problem. You can print that, no problem. This is my tuple. All right, so it didn't complain. It just printed out what you have entered. Also, you can use both double strings or single strings if you want. Double quotation mark or single quotation mark, it doesn't matter. But yeah, if we'll do A, for example, right, no problem. It's going to print everything. If you do like this, just to prove you, again, it's going to print it, no problem. So yeah, guys, this was an introduction to coding in Haskell. I might continue, doing these videos about Haskell programming, and eventually we can create a full course on Haskell programming language if you want. If you like my content, please leave a like, share, or do what you do. I don't know. Thank you so much for watching. Thank you so much, dear members, for supporting. And yeah, with that, I will see you in the next video. Till then, stay safe and be well. Take it easy, guys. First of all, you need to know that we use recursion in Haskell because there are no loops in Haskell.